Paper M1, European Qualifying Examination Reading and Listening Exercise. Barış Atalay. Description of the application. The invention relates to data input devices for computers, such as joysticks and graphics tablets.
Teaching note: always start by identifying the technical field. This tells you what kind of prior art to expect. Data input devices is the general category. Joysticks and graphics tablets are two embodiments, one mechanical, pivoting, and one planar. Mentally file this. Different physical forms, same underlying function, that is, input of position data.
A joystick comprises a movable operating element, hereinafter referred to as an actuator. The actuator can pivot in any direction about a fixed point. A joystick is used to input data representing the position of the actuator to a computer, for example in a flight simulator.
Teaching note: paragraph 2 and paragraph 3 define background art within the field. When you see the verb comprises, note the core functional element, here the actuator. The purpose is to provide positional data. You will later argue that the invention improves the accuracy of this positional data.
A graphics tablet comprises a panel and a freely movable operating element, hereinafter referred to as an actuator. A graphics tablet is used to input data to a computer by moving the actuator relative to the panel. The data represents the position of the actuator with respect to the panel. A graphics tablet can, for example, be used to control the position of a cursor on a screen, or for drawing with a computer-aided drawing program.
Teaching note: the same functional principle applies to both devices, namely position to output to computer. This hints that a single independent claim might cover both joystick and tablet. The movement type differs, pivot versus planar, but the invention lies elsewhere, namely in how position is determined electronically.
Document D1 discloses a prior art joystick. It comprises an actuator and a hollow, hemispherical, and electrically insulating support on which a resistive layer is arranged. The resistive layer is a band in the form of a spiral. The resistive layer is connected to a voltage supply via contacts at the ends of the band. The voltage varies linearly along the band with distance to either of the contacts. The actuator comprises a conductive element at one of its ends. When the conductive element is in contact with the resistive layer, it picks the voltage off the resistive layer at the contact point. The voltage picked off is characteristic of the position of the actuator.
Teaching note: this paragraph imports document D1 directly. When a prior art document is summarized inside the description, you can cite it as acknowledged prior art in your reply. Focus on structure. Resistive spiral layer leads to a voltage gradient. Contact tip picks voltage. Position is inferred from voltage. These correspond to features 1 to 3 of Claim 1 later on. Keep this mental map. You will compare every claimed feature to this baseline to locate distinguishing features.
A problem with the joystick of D1 is that the determination of the position of the actuator is inaccurate for two reasons. Firstly, the conductive element picks off the same voltage at all points lying on a line across the band at a given distance from one of the contacts. Secondly, no voltage can be picked off when the conductive element is directly in contact with the insulating support in the separating region between adjacent turns of the band. The above problem is solved by the subject matter of the appended claims.
Teaching note: this paragraph provides the explicit statement of the technical problem. Problem 1 is lack of uniqueness, same voltage on equipotential lines. Problem 2 is dead zones, no voltage at separating regions. These will later anchor the objective technical problem in your inventive step reasoning. Suggested neutral wording is how to enable accurate and continuous determination of actuator position on a resistive surface. Also note the phrase, solved by the subject matter of the appended claims. This means the invention that follows specifically addresses these 2 points. Do not add new aspects later to avoid an Article 123(2) issue.
Figure 1 is a perspective view of a data input device according to a first embodiment of the invention, with part cut away.
Teaching note: whenever you see figure introductions, mark them as basis for structural claim language, for example, as shown in Figure 1. Do not claim drawing conventions like part cut away.
Figure 2 is a block diagram of the components of the device of Figure 1.
Teaching note: a block diagram almost always introduces functional components such as switch, processor, and clock. Expect these to provide distinguishing means that give novelty over documents D1 and D2.
Figures 3A and 3B are schematic plan views of the resistive layer of the device of Figure 1.
Teaching note: schematic plan views show electrical behavior such as equipotential lines. This is the visual support for first and second voltage distributions. Mark these as direct support for the means for alternately generating feature later in Claim 3.
Figure 4 is a perspective view of a data input device, according to a second embodiment of the invention with part cutaway.
Teaching note: the second embodiment, flat support plus telescopic actuator plus spring, is explicitly supported here. Flag it because the client later requests to claim this separately. Keep a note that embodiment 2 is a spring-loaded flat joystick.
Figure 5 is a perspective view of a data input device, according to a third embodiment of the invention.
Teaching note: this is the graphics tablet version. The examiner may object that it overlaps D2, so expect to use this figure as a fallback variant rather than part of the main claim.
As shown in Figure 1, a joystick 1 according to the invention comprises a hollow, hemispherical, and electrically insulating support, 2, which is closed by a cover 3. An actuator 4 is pivotally mounted at the center of the cover 3 by means of a ball joint. The ball joint comprises a ball 5 arranged on the actuator 4 and a socket arranged in the cover 3 for retaining the ball.
Teaching note: this starts the first embodiment. Identify parts: support 2, cover 3, actuator 4, ball 5. These structural items are largely conventional. Keep only what contributes to the inventive concept in the independent claim. Hemispherical support 2 later supports a dependent claim. The ball joint is mechanical and need not be in the main claim unless required for function.
The interior surface of the hemispherical support 2 is provided with a resistive layer 6. The resistive layer 6 is preferably coated directly on the support, but it could also be fixed to the support by means of an adhesive layer. The actuator 4 comprises a conductive element 8 at one of its ends. The conductive element 8 is in contact with the resistive layer 6. The conductive element 8 is electrically connected to a control unit 9 via contact areas on the ball 5 and on the socket of the ball joint. The control unit 9 is mounted on the cover 3.
Teaching note: this sets the base electrical architecture. Resistive layer 6 on support 2, and a signal path from conductive element 8 to control unit 9. This supports the wording, a resistive layer arranged on the support, and a conductive element for picking voltages off the resistive layer. Note that in contact provides basis for movable contact language.
A first pair of contacts A and B and a second pair of contacts C and D are provided at the periphery of the resistive layer 6. The resistive layer 6 can be connected to a voltage supply via the contacts A, B, C, and D. As shown in Figure 2, the control unit 9 comprises a switch 91, which alternately connects the first pair of contacts and the second pair of contacts to the voltage supply for consecutive time periods T1 and T2, repeating. The time periods T1 and T2 are defined by a clock 93. During each first time period T1, a voltage minus V is supplied to contact A, a voltage plus V is supplied to contact B, and contacts C and D are disconnected from the voltage supply. During each second time period, T2, a voltage minus V is supplied to contact C, a voltage plus V is supplied to contact D, and contacts A and B are disconnected from the voltage supply. In this way, a first predetermined voltage distribution on the resistive layer during the time periods T1 is alternated with a second predetermined voltage distribution on the resistive layer during the time periods T2.
Teaching note: this is the core inventive mechanism. Key phrases are alternately connects for consecutive time periods, defined by a clock, and first and second predetermined voltage distributions. These provide support for means for alternately generating and for synchronization by a clock. These elements will move into the new independent claim to restore novelty.
Figure 3A shows the voltage distribution during time periods T1. Figure 3b shows the voltage distribution during time periods T2. The dashed lines represent equipotential lines on the resistive layer 6. Equipotential lines are defined as lines linking points at which the voltage is the same at a given moment in time. In other words, during one of the time periods T1 or T2, the voltage picked off by the conductive element is the same at any point on a given equipotential line.
Teaching note. This visually supports the predetermined distribution concept. It also explains why a pair of voltages V1 and V2 can identify a unique point. Use this in arguments to link structure to technical effect.
Referring to figures 2, 3a, and 3b, the determination of the position of the actuator 4 will now be explained as follows. Let us consider that the actuator is not moving and that the conductive element is in contact with the resistive layer 6 at a point P. During the time period T1, the point P lies on the equipotential line V1, and the conductive element picks off the voltage V1. During the time period T2, the point P lies on the equipotential line V2, and the conductive element picks off the voltage V2. The combination of the voltage V1 in time period T1 and the voltage V2 in time period T2 uniquely characterizes the point P. As shown in Figure 2, the control unit 9 includes a processing unit 92 that receives voltages picked off by the conductive element and a clock signal from the clock 93. The processing unit 92 is synchronized with the switch 91 by means of the clock 93. The processing unit 92 converts a pair of voltages, V1 and V2 picked off in consecutive time periods, T1 and T2, into an output signal for a computer representing a pair of coordinates, x and y, of the point P.
Teaching note. This gives functional causality. The distinguishing interaction is that the processing unit is synchronized with the switch by the clock. This linkage is absent in D1 and is purposefully different in D2. It delivers the technical effect of unique and continuous position determination.
In practice, the actuator is usually being moved by a user. In order to ensure that, even when the actuator is being moved quickly, the output signals accurately represent the actual positions of the actuator, the time periods T1 and T2 have to be very short. For example, each of the time periods T1 and T2 can be 0.01 seconds.
Teaching note. This provides explicit support for a quantitative dependent claim about short time periods. Keep it as a dependent claim, rather than essential to the main claim unless needed as a fallback.
Figure 4 shows another joystick 11, which is a second embodiment of the invention. This joystick has a flat support 12 on which a resistive layer 16 is coated or glued, a cover 13, and a telescopic actuator 14. The actuator comprises a conductive element 18 at one of its ends and a spring 20, which urges the conductive element 18 onto the resistive layer 16. This ensures that the conductive element 18 is in contact with the resistive layer 16 for all positions of the actuator. All other parts of the joystick correspond to those of the first embodiment.
Teaching note. This paragraph is the basis for a dependent claim requested by the client. Keep the three structural elements together in one claim. That is, flat support, telescopic actuator, and spring that urges contact. Using spring alone would risk added subject matter.
Figure 5 shows a graphics tablet 21, which is a third embodiment of the invention. This graphics tablet comprises a panel and an actuator 24 which can be freely moved. The panel comprises a flat support 22 on which a resistive layer 26 is coated or glued. A first pair of contacts A and B and a second pair of contacts C and D are provided at the periphery of the resistive layer 26. The actuator 24 comprises a conductive element 28 at one of its ends. The conductive element 28 is electrically connected to a control unit 29 via a cable 30, which passes through the actuator 24. The control unit 29 is mounted on a side of the support 22 and supplies voltages to the contacts A, B, C, and D.
Teaching note. This begins the tablet embodiment. It is structurally similar to the joystick in electrical terms, but uses a freely movable actuator and a cable connection. This supports a dependent claim for a freely movable actuator.
A user manipulates the actuator 24 like a pen. so that the conductive element 28 makes contact with the resistive layer 26 and picks voltages off the resistive layer. As described in conjunction with the first embodiment, the control unit 29 converts voltages picked off by the conductive element 28 into output signals for a computer. These output signals represent coordinates of the points of contact of the conductive element 28 with the resistive layer 26 and may be used by the computer to create drawings.
Teaching note. This is functional description only. It supports the unification of joystick and tablet under one independent claim, because the same alternating and synchronized principle applies.
Figure 5 furthermore shows selection zones 31 and 32, which are graphically represented on the resistive layer 26, for example by printing with conductive ink. If the user wishes to draw thick lines with the computer, he brings the conductive element into contact with the resistive layer within the selection zone 31. After the computer has received output signals representing positions of the conductive element 28, anywhere within the selection zone 31, it draws thick lines. In the same way, the selection zone 32 can be used to instruct the computer to draw thin lines.
Teaching note. This is an optional feature that can be used as an extra dependent claim. It introduces selection zones implemented, for example, by conductive ink. Treat it as fallback, not as part of the core novelty mechanism.
Document D1. The invention relates to a joystick. Joysticks are used as data input devices for computers.
Teaching note. The first sentence defines the field, identical to your invention. This confirms D1 is very close prior art. It will be the main reference for lack of novelty concerning the joystick version.
Figure 1 shows a known potentiometer, 101, which can be used as a data input device for a computer. The potentiometer, 101, comprises a flat elongate support 102 and an actuator, 104. A resistive layer, 106, is coated on the support, 102. The resistive layer is a straight band. The resistive layer is connected to a voltage supply via a pair of contacts, A and B. The contact A is located at a first end of the band and a constant voltage minus V is applied to it. The contact B is located at a second end of the band and a constant voltage plus V is applied to it.
Teaching note. This paragraph introduces the basic potentiometer principle, resistive band between two fixed voltages, correspondences to your first claim, support, resistive layer, actuator, contacts. No time dependence or alternating voltage is mentioned. Note this gap for later novelty argument.
The actuator, 104, comprises a conductive element, 108. The conductive element, 108, is in contact with the resistive layer, 106, and picks the voltage off the resistive layer. The actuator is configured so that the conductive element can slide along the band between the contacts A and B. Because the voltage varies linearly along the band, with distance to either of the contacts, the position of the actuator. 104 can be derived from the voltage picked off by the element 108.
Teaching note. This is the key operating principle of D1, a single static voltage gradient, one reading at a time. Your invention differs by using two alternating voltage distributions and clock-based synchronization to avoid ambiguity.
Our invention is a joystick which is based on the principle of operation of the potentiometer described above. As shown in Figure 2, the joystick 111 comprises a hollow, hemispherical, and electrically insulating support 112, which is closed by a cover 113. An actuator 114 is pivotally mounted at the center of the cover by means of a ball joint. The ball joint comprises a ball 115 arranged on the actuator and a socket arranged in the cover for retaining the ball.
Teaching note. This converts the flat potentiometer into a three-dimensional joystick. Geometry and pivoting are disclosed here, so you cannot rely on those for novelty.
The interior surface of the hemispherical support, 112, is provided with a resistive layer 116. The resistive layer is a continuous band in the form of a spiral. A narrow separating region, 120, of the support, 112, electrically isolates adjacent turns of the band. The resistive layer, 116, is connected to a voltage supply in a control unit, 119, via a pair of contacts, A and B, located at the ends of the band. The control unit 119 is mounted on the cover 113.
Teaching note: note the spiral resistive band. This design creates ambiguity and gaps, the very problems your invention solves. Keep the wording "narrow separating region" ready for your problem statement.
The actuator 114 comprises a conductive element, 118 at one of its ends. The conductive element 118 is in contact with the resistive layer 116 and picks the voltage off the resistive layer at the contact point. Since the voltage varies linearly along the band with distance to either of the contacts, the voltage picked off is characteristic of the position of the actuator. The conductive element 118 is electrically connected to the control unit 119 via contact areas on the ball and the socket of the ball joint. The control unit 119 comprises a processing unit for converting the voltages picked off by the conductive element into output signals for a computer in the form of pairs of coordinates that represent positions of the actuator 114.
Teaching note: this confirms that D1 already includes a processing unit converting voltage to coordinates, but with no timed alternation or clock. Highlight this absence when distinguishing your claim.
When the conductive element 118 is in contact with the separating region 120, no voltage is picked off. As soon as the control unit 119 senses this condition, it continues to generate the output signal derived from the voltage previously picked off by the conductive element 118. In this way, the control unit 119 continuously generates an output signal that approximately represents the position of the actuator 114.
Teaching note: D1 explicitly admits its weakness. Dead zones cause missing data, and the control unit merely extrapolates previous values. Your invention solves this by providing two alternating voltage patterns, so at least one reading is always valid. Summary: D1 shows a joystick with hemispherical support, resistive spiral, fixed voltages A and B, single static gradient, a processing unit that estimates position from one voltage, problems of inaccuracy in dead zones, no alternating voltages, no clock, no synchronized switching. This defines the closest prior art for novelty and inventive step discussion.
Document D2. Our company has developed a data input device for computers and vending machines.
Teaching note: this defines the technical field. It overlaps with the inventions field, data input devices, but the application context differs. D2 is therefore a good prior art for the planar or tablet embodiment, not for the joystick.
Figure 1A shows one of our devices designed for a computer-based questionnaire. It has a panel 201 and a stick 204. As shown in Figure 1A, the stick 204 can be used as an actuator to select one of three possible answers.
Teaching note: this is the first form of D2. It introduces a stick acting as an actuator for a flat panel. Compare this to your graphics tablet embodiment. Both determine position by surface contact, not pivoting.
Figure 1B shows one of our devices designed for a hot drinks vending machine. It also has a panel 201 and a stick 204 that can be used as an actuator to select a drink. As shown in Figure 1B, a selection can also be made with a finger.
Teaching note: the actuator in D2 can be either a stick or a finger. This means the actuator is freely movable and not fixed to a pivot. That makes D2 relevant for your tablet version claim about a freely movable actuator.
Figure 2 shows a partial section through the device of Figure 1B. The stick 204 is shown being pressed against the panel 201 in order to select a drink.
Teaching note: operation in D2 is pressure-based. The signal occurs only when pressure is applied. In contrast, your invention has continuous electrical contact. This functional difference will be central for novelty and inventive step.
The panel 201 has a rigid support 202 made of electrically insulating material, a conductive layer 208, an electrically insulating gel layer 207, a resistive layer 206, and an electrically insulating protective layer 205 are provided on the rigid support 202 in this order. Each of the layers is continuous and covers the entire support. The resistive layer 206 and the protective layer 205 are relatively thin so that they deform when pressure is locally applied to the panel 201. The conductive layer 208 is electrically connected to a control unit.
Teaching note: list the layers carefully. Support: conductive layer, gel, resistive layer, protective layer. Note the phrase continuous and covers the entire support. This wording appears in your claim too, which is why the examiner found it not novel. For amendments, you will remove continuous from your main claim to allow discrete layers, as the client requested.
As shown in Figure 2, when the stick 204 is pressed against the panel 201, the protective layer 205, the resistive layer 206, and the gel layer 207 are locally deformed until the resistive layer 206 is in electrical contact with the conductive layer 208. The gel layer 207 is thick enough to prevent unintentional contact between the resistive layer 206 and the conductive layer 208, for example, when a user merely touches the panel without applying significant pressure.
Teaching note mechanism summary: voltage is detected only when layers touch due to pressure. Your invention differs fundamentally. No deformation, always on contact between conductive tip and resistive layer. This is a strong argument under novelty and also supports a different technical effect: continuous coordinate tracking.
The stick 204 must be blunt, so that when it is used to exert pressure on the panel, the resistive layer 206 and the protective layer 205 are not punctured. The use of a blunt stick or a finger, furthermore, results in a relatively large area of contact between the resistive layer 206 and the conductive layer 208. Therefore, a reliable electrical contact can be achieved.
Teaching note: large area pressure contact is the opposite of your fine point contact design. Use this in your argument. D2 relies on mechanical deformation and large contact surfaces, whereas your system relies on quick electronic switching.
We will now explain how our device functions with reference to figures 3A and 3B. A first pair of contacts, A and B, and a second pair of contacts, C and D, are provided at the periphery of the resistive layer 206. The resistive layer 206 can be connected to a voltage supply in the control unit via the contacts A, B, C, and D. The control unit comprises a switch which alternately connects the first pair of contacts and the second pair of contacts to the voltage supply for consecutive time periods, T1, T2, T1, T2, and so on. During each first time period T1, a voltage minus V is supplied to contact A. A voltage plus V is supplied to contact B, and contacts C and D are disconnected from the voltage supply. During each second time period, T2, a voltage minus V is supplied to contact C, a voltage plus V is supplied to contact D, and contacts A and B are disconnected from the voltage supply. In this way, a first predetermined voltage distribution on the resistive layer during the time periods T1 is alternated with a second predetermined voltage distribution on the resistive layer during the time periods T2.
Teaching note: at first sight, D2 seems to disclose the same alternation as your invention. However, the timing and purpose differ. D2 alternates slowly and not for continuous coordinate tracking. To regain novelty, you will rely on the faster clock and synchronization in your system.
Figure 3A shows the voltage distribution during time periods T1. Figure 3B shows the voltage distribution during time periods T2. The dashed lines represent equipotential lines on the resistive layer 206.
Teaching note: this confirms that D2 does include equipotential lines and alternating potentials, but again without describing timing or synchronized processing. Keep this distinction explicit.
When the stick or a finger is pressed against the panel so that the resistive layer 206 is brought into contact with the conductive layer 208, the conductive layer 208 picks 2 voltages off the resistive layer 206 in 2 consecutive time periods. The combination of a first voltage in time period T1 and a second voltage in time period T2 characterizes the contact area between the resistive layer 206 and the conductive layer 208, and therefore also the area of the panel on which pressure is exerted. Time periods T1 and T2 of 0.25 seconds have proven to be long enough to reliably detect whether pressure is exerted in this area.
Teaching note. This paragraph gives the quantitative distinction. Your invention uses very short periods of 0.01 seconds, whereas D2 uses 0.25 seconds. This difference allows you to argue that your device operates continuously and rapidly, unlike D2, which merely detects static pressure events.
The control unit comprises a processing unit which is synchronized with the switch and generates output signals based on the first and second voltages. For example, as shown in Figure 1b, when the user wishes to have a large coffee, he pushes on the panel within the corresponding selection zone 203. The processing unit then receives voltages characterizing a region within this selection zone and generates an output signal instructing the hot drinks vending machine to prepare a large coffee.
Teaching note. Be careful with the phrase processing unit synchronized with the switch. In D2, this means only that the data reading matches the contact detection timing, not that it tracks continuous coordinates. In your invention, synchronization is controlled by a clock for continuous position mapping. Highlight this difference clearly in your reply letter. Summary of D2 device type: pressure-based panel. Operation: resistive layer touches conductive layer under pressure. Voltage alternation: yes, but slow, 0.25 seconds. Synchronization: yes, but only event-based, not continuous. Technical effect: detect zone selection. Distinction: your invention uses faster clock-controlled alternation for continuous coordinate determination, not just touch detection.
Communication pursuant to Article 94, Paragraph 3 EPC. Reference is made to the following documents, D1 and D2. The document D1 has been cited by the applicant in the description. Both documents were published before the priority date of the present application.
Teaching note. The examiner begins by establishing the prior art base. Always note which documents are admitted as pre-published. This determines the scope of novelty objections. You do not need to challenge this unless the examiner has used a wrong date or non-relevant category.
The present application does not meet the requirements of Article 52, Paragraph 1 of the European Patent Convention, because the subject matter of Claims 1 to 4 and 6 to 8 is not new, in the sense of Article 54, Paragraphs 1 and 2 of the Convention.
Teaching note. This sentence sets the overall objection. The reason is lack of novelty. Article 52, Paragraph 1 simply states that inventions must be new and inventive. Article 54 defines what new means. The phrase Claims 1 to 4 and 6 to 8 tells you which claims are objected to. Claim 5 may be untouched because it is limited to a feature not found in the cited article. You will verify this before deciding what to amend.
The subject matter of Claims 1, 6, and 7 lacks novelty with respect to D1. Claim 1, Document D1 discloses, see paragraphs 4 to 6, and Figure 2, a data input device 111 for a computer comprising a support 112, a resistive layer 116, which is arranged on the support 112, and which is connectable to a voltage supply, a movable actuator 114, a conductive element 118 for picking voltages off the resistive layer 116, and a processing unit in the control unit 119 for converting the voltages into output signals for the computer which represent positions of the actuator.
Teaching note. Here the examiner performs a feature-by-feature mapping from Claim 1 to D1. Observe that no mention is made of any clock, switch, or alternating voltage distributions. These omissions will form the basis of your amendment and argument for novelty.
Claim 6. The data input device disclosed in D1 is a joystick. See paragraph 4.
Teaching note. Claim 6 adds the word joystick. D1 already has that, so it gives no distinction.
Claim 7. The support 112 of the data input device disclosed in D1 also has a hemispherical shape. See paragraph 4.
Teaching note. Claim 7 only defines the shape of the support. D1 discloses that as well, so this dependent claim also lacks novelty. This confirms that geometric changes alone cannot restore novelty.
The subject matter of Claims 1 to 4 and 8 lacks novelty with respect to D2. Claim 1. Document D2 discloses. See paragraphs 1, 5, 6, 10, and 11, and Figure 2, a data input device for a computer comprising a support 202, a resistive layer 206, which is arranged on the support 202, this expression not excluding intermediate layers, and which is connectable to a voltage supply. A movable actuator, stick 204, a conductive element, conductive layer 208, for picking voltages off the resistive layer 206, and a processing unit for converting the voltages into output signals for the computer, which represent positions of the actuator. The output signals depend on the position of the stick 204 on the panel 201.
Teaching note. This mapping is very close to your Claim 1. The examiner equates the conductive layer 208 with your conductive element, and the stick 204 with your actuator. You will argue that D2 is pressure-based and does not provide continuous positional data, whereas your device does. That difference is implicit, not structural, so you will add structural timing features to make it explicit.
Claim 2. The resistive layer 206 of the data input device of D2 is continuous and covers the entire support. See paragraph 5.
Teaching note. This directly matches the wording of your current Claim 2. To overcome the objection, you may remove the adjective continuous from your main claim so it covers discrete layers. You can then retain the continuous case as a dependent claim.
Claim 3. The data input device of D2 further comprises means, pairs of contacts A, B, and C, D, and a switch, for alternately generating a first voltage distribution and a second voltage distribution on the resistive layer. See paragraph 8. Said means being synchronized with the processing unit. See paragraph 10.
Teaching note. This is the examiner's critical reasoning. D2 already alternates voltage distributions and states that the processing unit is synchronized. Your counter-argument will emphasize that D2's synchronization is not clock-controlled, that the time intervals are long, and that the device is designed for pressure detection rather than continuous coordinate tracking.
Claim 4. The data input device of D2 further comprises all the features of Claim 4. See point 2-2-3 above.
Teaching note Claim 4 is therefore also read onto D2. To regain novelty, you must show a structural or functional difference beyond those features. For example, explicit synchronization by a clock defining short consecutive periods.
Claim 8. The actuator, stick 204, of the data input device of D2 is freely movable. See paragraph 3 and figure 1b.
Teaching note. The examiner uses the word freely movable exactly as in your Claim 8. That means this claim also lacks novelty. However, you can retain it as a dependent claim to link with the graphics tablet embodiment after the main claim is amended.
The applicant is invited to file new claims which take account of the above objections.
Teaching note. This is the formal invitation to amend. Under Article 94, Paragraph 3, the examiner expects you to respond by explaining amendments and giving arguments for novelty. You must file a complete set of amended claims and a reasoned letter. Always identify which features restore novelty and where they are supported in the description to meet Article 123, Paragraph 2. Teaching summary for the communication. The examiner bases lack of novelty for Claims 1, 6, and 7 on D1 and for Claims 1 to 4 and 8 on D2. The shared problem is that both prior arts already disclose the structural arrangement. You must rely on timing, synchronization, and functional differences. The invitation to amend triggers your drafting of the reply letter.
Letter from the applicant. Dear Mr. Spielbub, despite the negative communication of the European Patent Office, we are confident that you will be able to help us to obtain patent protection for all the embodiments of our invention.
Teaching note. This establishes tone and scope. The client expects protection for all embodiments, not just the joystick. Always keep the client's intention in mind, but stay within EPC compliance. Your reply must therefore balance breadth of protection with clarity and novelty.
We wish to prevent any of our competitors from later being able to work around our patent by producing a data input device having a plurality of discrete resistive layers arranged side by side on a support. Please ensure that any amended independent claim you file does not exclude such a device.
Teaching note. This is a strategic drafting instruction. The client wants protection broad enough to cover multiple, discrete resistive areas, not only one continuous layer.
Legal interpretation. If Claim 2 said continuous resistive layer covering the entire support, that wording would exclude the discrete version. Therefore, delete the word continuous from the main claim and, if desired, reintroduce it as a dependent claim. This adjustment also helps distinguish from D2, which uses a continuous resistive layer. Please also ensure that the second embodiment of the joystick is claimed in more detail in the dependent claims you will file.
Teaching note. The second embodiment is the flat joystick with telescopic actuator and spring. From paragraph 17 of the description, its defining features are flat support, telescopic actuator, and spring ensuring contact. This can be protected by a dependent claim, for example, wherein the actuator is telescopic and urged by a spring to maintain contact with the resistive layer. This request is consistent with Article 84 EPC, clarity, and is supported by the description, so it is safe to implement.
Please file new claims which will achieve the broadest possible protection for our invention, taking the above comments into account.
Teaching note. The client's overall instruction. Maximize scope while remaining patentable. Your drafting objectives, therefore, are a main independent claim that is as general as possible but still novel over D1 and D2. Dependent claims covering specific embodiments, spring-loaded joystick, hemispherical support, graphics tablet, removal or rephrasing of potentially limiting terms like continuous to include discrete designs.
Yours truly, André Dudonnet.
Teaching note. Client letters are part of EQE paper reasoning. Every instruction in the letter must be addressed in your amendments. Examiners expect to see explicit evidence that you followed client requests. In your reply, refer directly to the client's directions, e.g., as requested by the client, the independent claim has been drafted so as not to exclude embodiments comprising discrete resistive layers. Teaching summary for the client letter. Strategic instruction. Maintain broad protection. Avoid excluding discrete resistive layers. Specific technical request. Explicitly claim the second embodiment. Flat joystick with telescopic actuator and spring. Drafting implications. Modify main claim wording. Remove continuous. Add dependent claim for the spring-loaded actuator. Communication principle. Show that both client wishes and EPC requirements are respected.
Summary. Teaching synthesis and reply letter. The goal is to show how a candidate extracts and structures information from the description, prior art, D1 and D2, the examiner's communication, and the client's letter to draft amendments and a reply. 1. Technical field and problem. The invention concerns data input devices for computers such as joysticks and graphics tablets. The problem is inaccurate position determination caused by equipotential ambiguity and dead zones. Objective technical problem. How to enable accurate and continuous position determination of an actuator on a resistive surface. Always describe the problem neutrally to satisfy Article 56 EPC on inventive step. 2. Embodiments. Embodiment 1. Hemispherical joystick with internal resistive layer, 4 contacts, a control unit with switch and clock, alternating voltages, and a synchronized processor. Embodiment 2. Flat joystick with telescopic actuator and spring-maintaining contact. Embodiment 3. Graphics tablet with freely movable pen-type actuator connected by cable. Each embodiment must be linked to paragraph numbers for support. Article 123 2 EPC. 3. Distinguishing features over prior art. D1 uses a static voltage gradient and has no timing or synchronization. D2 uses slow alternation, 0.25 seconds, only for pressure detection. The invention adds clock-controlled alternation with short 0.01 second periods, producing continuous coordinate tracking. These are the core novelty features. 4. Structure of the amended claims. Independent claim 1 should include the support, resistive layer, actuator, processing unit, alternating voltage means, switch and clock defining short periods, and synchronization by the clock. Avoid the word continuous, so discrete resistive layers are also covered. Dependent claims specify contact pairs, short time values, joystick variants, flat spring-loaded joystick, graphics tablet variant, and optional continuous layer as fallback. 5. Arguments for the reply letter. Novelty over D1. D1 has no alternating voltage or clock synchronization. Novelty over D2. D2 has long periods and pressure activation. Invention provides rapid, clock-based synchronization. Inventive step. Starting from D2, improving accuracy and speed. D1 would not motivate the skilled person to adopt rapid clock control. Clarity and support. All features supported in paragraphs 11 to 17, Articles 84 and 123(2). Client requests. Wording broad enough for discrete layers. Dependent claim for the flat spring-loaded joystick. All embodiments covered. 6. Strategy and drafting points. Reconstruct field problem effect before drafting. Base amendments strictly on supported paragraphs. Use examiner's references and precise, factual language. End with a courteous closing, requesting continuation of examination. 7. Understanding and responding to the communication. The examiner objects to lack of novelty for claims 1 to 4 and 6 to 8, based on D1 and D2. Group objections by document to answer clearly. The distinguishing feature is clock-controlled synchronization with short time periods. Amend Claim 1 to combine the structural base with alternating voltage and clock features. Retain dependent claims for embodiments and fallback. Cite supporting paragraphs to show no added matter. 8. Reply letter structure. Introduction. Identify the communication. Amendments. What changed and where supported. Novelty, D1 and D2 arguments. Inventive step, problem solution. Client compliance and EPC conformity. Conclusion, request continuation. Model closure. In view of the above amendments and arguments, the claims now meet the requirements of Articles 52 to 56 EPC. We respectfully request continuation of the examination on the basis of the enclosed claim set. 9. Key takeaways. Group objections by prior art. Find the minimal distinguishing feature. Amend only using supported text. Cite EPC articles. Keep tone factual and courteous. Postscript. Revisions incorporated. Short. Claim 1 clarity, breadth. Now recites a switch controlled by a clock to alternately generate first-second voltage distributions in consecutive periods. T1, T2, and a processing unit synchronized to the clock to associate consecutive samples for coordinates. Timing kept flexible. Specific value, 0.01 seconds moved to a dependent claim, keeps main claim broad. Layer scope broadened. Main claim uses a resistive layer arranged on the support. Optional, covering the entire support, placed in a fallback dependent claim. Avoided means for ambiguity. Structural wording with pairs of contacts, AB, CD, and the clock-controlled switch. Tablet claim safe. Keeps freely movable actuator without pressure, deformation limitations. Reply letter sharpeners. Novelty over D2. Explicit effect. Clock synchronized consecutive samples. V1 at T1, V2 at T2. Unique coordinates per instant, continuous tracking. Unlike D2's event-based zone detection. Inventive step bridge. Adopting rapid clock-driven alternation would fundamentally alter D2's pressure-triggered architecture. D1 offers no hint toward such timing control. Claim set sanity check broad device, clock plus sync. 2. Contact pairs. 3. T1 equals T to approximately 0.01 seconds. 4. Joystick/hemispherical. 5. Flat plus telescopic plus spring. 6. Tablet with freely movable actuator. 7. Continuous layer fallback.